Network design elements and components. You know, as you look at this list of 5 things that CompTIA wants you to know for this area of this domain of the Security Plus exam, it seems like kind of a hodgepodge of terminology. But the closer I look at this list, the more I'm just in total agreement with CompTIA, because all these network design elements and components are so critical from a security standpoint in the sense of understanding how they work in your network infrastructure and your security infrastructure. We're going to look first at demilitarized zones, which are also known as screened subnets or security zones, to use Cisco's vernacular. Then we're going to look at concepts like virtual LANs, VLANs, and network address translation, which on the surface look like security mechanisms when in fact they're not really security mechanisms, and this is an area where people can make a lot of mistakes assuming that these things secure your network. Then we're going to look at NAC or NAC. We'll talk about that, break down that acronym for you. And finally, telephony, and what role does it play in your network infrastructure as it relates to security? Let's look at these 5 interesting topics. Okay, our first concept is a demilitarized zone, and this concept's been around for quite a while, and I'm going to kind of define what it is, and then I'm going to give you a couple of scenarios that we see in small to medium-sized businesses and then in larger enterprise organizations. Now, a DMZ traditionally is an area that's on the perimeter of our network where we're going to place public servers, like public SMTP servers, DNS servers, e-commerce servers, FTP servers that are basically isolated into their own security zone, protected by a firewall from our internal organization. Now, we may have some limited access to that DMZ by hosts on the inside of our network, maybe management hosts, for example, but we have to carefully configure our firewall to protect our inside network from the DMZ. These servers and services in the DMZ are being exposed to the internet or to selected extranet partners. An extranet's kind of like a special inter-network between us and a partner or a customer or a vendor, things like that. So when you establish this DMZ, the assumption is that the people that are accessing those servers and resources aren't totally trusted. Okay, they're from the outside internet, and right here in our diagram, this is the untrusted network. Okay, I'll just put a big I there. It's the untrusted internet, or it's the extranet with the partner that we kind of trust but not completely. All right, so we want to also keep the rest of our internal networks, and in this situation this represents our internal networks on both sides, and this will make sense to you in here in a second. Okay, so in a nutshell, a DMZ is an option for separating public information, for example, our public DNS servers with our public namespace, from our private information, which may have a whole separate DNS namespace for our internal organization. For example, we might have publicly exposing to the internet, we may be exposing, let's say, cbtnuggets.com, but inside of our organization, we're using something like nuggetlab.com. Now, we've kind of moved away from this phraseology of DMZs into phrases called security zones. And so once we understand that this is a demilitarized zone, let's understand that we're kind of moving away from that into concepts of security zones, which Cisco, for example, really likes to come down on. So they'll have like the private zone. I'll just put PRIV here, the private zone. This would be the public zone, okay, going from this perimeter router or multi-layer switch to the internet, and then we would have a DMZ or a security zone. Now, realize that this DMZ isn't necessarily one single subnetwork or one single network, and I'll get into that a little bit more. And the newest feature, by the way, that Cisco has put out there, and I know this isn't a Cisco course, but Cisco is such a leader in this area, you really should know about this. This phrase won't be on your Security Plus exam, but they use what are called Zone-Based Policy Firewall, ZFW. So they use all of these firewall features from their security operating system to provide a whole bunch of different types of protections. Stateful packet inspection, filtering of the URLs, mitigating against denial of service attacks, and protecting a bunch of unsafe protocols like HTTP, POP3, IMAP, ESMTP, RPC, peer-to-peer file sharing, instant messaging applications like Microsoft's Messenger, Yahoo Messenger, AOL Instant Messenger. So, protecting against all these different types of protocols. Now, I think you get the idea for what a demilitarized zone is. Let me show you a couple of designs here. You have one that's called a three-legged or I'll use armed, three-armed firewall. And what you have here, this is used typically in small to medium-sized businesses, okay? SMB, small to medium-sized businesses, where you have, here's the internet. Coming into the internet is our perimeter router. Then behind the router is a firewall. A combination of, it could be a server with a firewall software on there. It could be Linux or Unix. It could be a router with firewall operating system features on it. It could be a dedicated PIX firewall, for example, or maybe one of the new Cisco ASA adaptive security appliances, or one of the other mini vendors all-in-one appliances. It's a single firewall box. Now, typically, you'll have two of these because you want to have some redundancy built in. But the bottom line is you have a single firewall with three arms: a public arm, a private arm, and a DMZ arm. So these are fast Ethernet or gigabit Ethernet interfaces. This one goes to the router. And don't get me wrong, this perimeter router does have its own security. It's using access control lists and filtering and things like that. But this firewall is really our main wall of defense between the outside network and our private network. Now, what we have out here in the DMZ is our public-facing services. These are the servers that these people on the outside on the internet and other companies, like maybe an extranet partner, should be accessing. We don't want them accessing servers on the other side of this firewall in our private network, on our inside local area network, our corporate LAN. Now, we're going to talk about VLANs or virtual LANs here in a second. I'll even mention private VLANs, and this is where we get our flexibility. For example, in our DMZ out here, typically this interface or gigabit Ethernet interface is connecting to a switch, either a layer 2 switch or a multi-layer switch. And then you've got your public servers plugged into the switch. Your DNS servers, your FTP servers, SMTP servers, e-commerce servers, just the list goes on. Anything that you need to your World Wide Web servers, don't forget those. Your public corporate exposure to the outside. Now, you'll have these servers plugged into this high-speed switch, but typically what you're going to do is you're going to use this firewall and or the switch together to create multiple zones in your DMZ. So in other words, your DMZ is not going to be one zone. It's going to be several zones all in their own VLAN or private VLAN, which is just a logical way to kind of create broadcast networks, and you're going to have each one of these be their own zone. So you could literally say, I'm going to have World Wide Web servers here, e-commerce servers here, and then I'm going to have SMTP servers here, but they can't communicate to each other, or they can only communicate with certain rules. That way, if let's say one of these servers is compromised in this security zone, it's not going to spread to all the other servers. That's the danger we have of putting all of our servers and services in one zone, one DMZ, is that because of trust relationships with Windows operating systems, for example, and other connectivity issues, we can have worms, for example, spread through all the servers in the zone. By creating these separate zones, we have our own secure zones. And these zones are simply just ports on the switch, or we use VLAN technology to logically do this with configurations. Now that's typically done at a 3-arm firewall. What you have over here is what we refer to often as a screened subnet you hear Microsoft use this solution. The bottom line is this. This is just extra layers of security. Here's our perimeter router. Let's go to this other company. Here's our perimeter router, okay? Obviously, this router is going to have some access control filters on it. It's going to have some security, but you're going to let a lot of traffic through here. Then you've got a firewall, which is your first line of defense. Then between this firewall and another firewall, you've got a switch, maybe a layer 2 or layer 3 switch. You've got two firewalls now protecting your corporate network. So if they have to get past two firewalls. This switch right here is going to service, this is your DMZ, or multiple security zones, where you've got your ZFW going on, you've got your other policy-based or zone-based firewalls. And so you've got this switch that services these particular zones. It's in between two firewalls. So you get extra layers of security. This is what you see more common in medium-sized businesses to enterprise organizations. So hopefully this little chicken scratch here gives you a really good idea of what we're talking about. Especially from the Security Plus exam, you have more information than you possibly would need to tackle the DMZ concept on that exam. All right, right on. A VLAN or a virtual LAN is the capability on a layer 2 switch to create a virtual or simulated network or subnetwork in the same way that routers do. Now, the advantage to this is that no matter where a particular host or a server or workstation is located, they can all be a member of the same broadcast domain. Look at it this way. You've got over here in this area, you may have individuals from IT and human resources all on the same subnetwork or subnetworks, network 1 through network 4. Over here you've got sales and marketing on networks 2.1 through 2.4. Then over here we've got finance and accounting 3.1 and 3.4. And the beauty of this is if you turn this over and made this vertical instead of horizontal, these could be 3 different floors of a building, for example. Think about this. If I had 5 floors of a building, and I wanted to have individual people from the Human Resources Department represented on each floor of these 5 floors of the building. I wanted to have 2 or 3 people spread out throughout the entire organization to facilitate my organization and human resources. In other words, I don't want them all that to be located in one small area. They need to be interacting with the employees, interacting with a wide variety of different types of people, different purposes. What I can do is I can spread them out throughout the entire organization, and I can use configurations on these switches to simply say you're in VLAN HR, you're in VLAN HR, you're in VLAN HR, and so on. So I could have 30 people spread out over 5 floors of a building, all in the same broadcast domain. Now, where security comes in is that VLANs originally gave network engineers a false sense of security, because they said, look, if I've got all 30 of these HR people in the same VLAN, they're broadcasting and communicating in their own subnetwork, no matter where they're at. That's security, because VLANs, you can't communicate from one to the other unless I allow them to route between each other. The problem is they started to discover that there were certain kinds of attacks that could be used called VLAN hopping on the communications between these switches. These switches are all trunked together, and they use special types of frames, either ISL frames or 802.1q. Let me jot those down. Old Cisco ISL or 802.1q, special types of frames that allow all these switches to be trunked together so that individuals can be spread out but still be part of one VLAN. The problem is they could exploit the fields in this frame to do what's called VLAN hopping and basically hop from one VLAN to the other. So VLANs are not a security mechanism. They're really a way to create broadcast domains or subnetworks in large organizations. It also allows us to create an IP addressing scheme that's hierarchical, hierarchical and distributed in an orderly, sequential fashion, which allows me to take advantage of things like variable length subnet masking to create very, very tight, efficient subnetworks and have very efficient routing tables on these multi-layer switches and core multi-layer switches, which are also routers in our network. by doing this and using this tight IP addressing scheme with VLANs, we can also create what are called failure domains. All right? If I have a problem where I have to troubleshoot, it's easier to isolate that down into individual VLANs or subnetworks instead of having to troubleshoot the entire organization. So again, VLANs are not a security mechanism, but they can be used in combination with security, especially if you go back to the previous slide where I was talking about DMZs. We can use VLANs and what we call private VLANs out in those security zones to separate those servers from each other. And we can use techniques on the switches as well to protect ourselves from these attacks like VLAN hopping and issues like that. So VLANs can come into play in the sense that we can use them as facilitators for our security zones. Now, another protocol or service that's also confused with security is network address translation. Now, NAT provides security really only in the sense that it allows us to hide our internal IP addressing structure from the outside world. In other words, we can use inside of our network one of those private addresses, the 10.0.0 range of class A, the 172.16 range of class B, and the 192.168 range of class C. We can use these private ranges inside of our organization. I'll put a little dividing line here. Inside of our organization, but on the outside, to the outside world, we can go to the ICANN and get a valid public IP address. I'm just going to grab one out of my hat here. I don't even know who this belongs to, so please don't go here on the internet. But I have a public IP address that represents my network, so I'm hiding my internal address scheme by doing address translation. And I've got lots of capabilities here in doing this. For example, let's kind of go back to what we were talking about earlier, where I might have this as a firewall device, or it's a router that runs firewall software. I've got that DMZ down here, don't I? And in that DMZ, I've got a bunch of public servers. Maybe they're all in their own zones. And then here, of course, is my internal network, which maybe it's using, let's say, address 172.16.1.0. Maybe with a 22-bit mask, we'll say. So we're using this as our internal addressing scheme. Now, I don't want the outside world to know this scheme. I'm going to be able to translate this into a public IP address. Well, I have the capability to basically use on this router here what's called port address translation, which is a feature of NAT, so that everybody on the outside world here, on the untrusted internet, basically who wants to send traffic to my inside network is going to send it to this address, okay? So whenever sessions are created with inside hosts to servers on the outside, basically the servers are seeing this as the source IP address. What's happening here is there's a translation being done from my internal IP addressing, and what's happening is they're taking this address and they're combining it with port numbers, basically anything over port 1024, and they're combining IP addresses and port numbers to create what are called sockets. And so the PAT device, or the network address translation device, is remembering the sockets and doing all the translations for me. So even though this particular server out here is going to respond back to an internal client to this IP address, this NAT device has remembered the session, okay? It has the session state in memory, and it knows that particular packet from that particular session goes to a device of address 172.16.1.10, and then a particular port number like 2022. So it does this translation for us. That's a great thing. I can represent internal addresses by one single address. Or I could have a block of addresses. I could have 209.100.1.1 through 1.5, for example. And I can use that. I'm overloading my internal addressing scheme, representing it this way. But I could do, if I wanted to, I could do static mappings of a single internal host to a NAT global address if I wanted to do it that way as well. I could have a host at, let's say, 172.16.1.10 be translated to 209.100.1.6, for example, kind of a one-to-one mapping. I have that capability. The other cool thing is I can allow servers in my DMZ to either be exposed using public IP addresses, or I could do network address translation on these servers as well, so that these public servers are seen by a public IP address, but in the DMZ I'm using some other range like 192.168.100.1 through 10, representing all 10 of my servers in there. So network address translation gives us a way to basically hide our internal private addressing structure, which we're using now because the IP version 4 address space is basically almost depleted. So this is really kind of a workaround to get by the limitations of that 32-bit address. It's not security, okay? It can hide internal IP addressing, all right, and it can facilitate us with our firewalls and things like that, but it is not a security mechanism. So again, you don't want to false sense of security with VLANs or network address translation. They're part of our security planning and our security policy, but they're not security mechanisms. Okay, let's look at some bullet points. I know you missed my bullet points, so let me go ahead and give you some as we talk about Network Admission Control, or NAC. NAC, I can really actually talk about Cisco now because CompTIA wants you to understand what NAC is, and this is an initiative driven by Cisco. It's an industry initiative, okay, so it goes across the board, but it's sponsored by Cisco. Microsoft House also has their own initiative called NAP, and they're actually partnering up with Cisco to deliver NAC-NAP as listed here. We aren't really concerned for this exam about NAP or NAP. We're concerned with NAC, NAC. And what happens with NAC is this. We're using the network infrastructure to basically enforce security policy compliance on any device that tries to get access to network resources. And the goal here is to limit the damage from destructive viruses and worms and other types of malware. So using NAC, the customer or your company could basically say, we're only going to allow network access if the endpoint device is trusted, if they're compliant. In other words, if they are up to date on their antivirus, anti-spyware, and other security mechanisms. So this can apply to PCs, to laptops, to servers, to PDAs, all different types of devices that try to get access to the network, including wireless devices. So we're going to restrict the access of a non-compliant device. And that really helps if somebody walks into our organization with a rogue laptop or a rogue handheld device. Okay? Now, the NAC is part of Cisco's what they call the self-defending network. But the industry terms here are not self-defending network. The industry term is defense in depth. Layers of defense or layered security. So a company that implements network admission control is basically adding another layer, another defense in depth. And this is often used in combination with agent software that is running on all these devices to make sure that they're compliant, trusted endpoint devices, working to proactively defend against malware attacks, enforcing compliance of our security policy. And the goal here is to significantly reduce the impact and the instances of viruses and worms and any other type of distributed denial of service attack that comes from logic bombs or Trojan horse programs or rootkits or backdoors. So that's the goal here. Well, last but certainly not least is telephony, IP telephony, or voice over IP, which is basically sending traditional voice traffic over your packet switched IP network. It's an exploding, emerging technology which is allowing organizations to use telephony in a very inexpensive way using existing data channels, wired and wireless channels, and they can manage it in the same infrastructure as their traditional IP traffic. But it opens up a whole new Pandora's box of vulnerabilities. Now we have phone conversations in the corporate environment that can have sensitive information now going across our wires that can be sniffed, man-in-the-middle attacked, and even retrieved and stored as data files. Also, we have more and more companies leveraging inexpensive channels with DSL and cable and satellite over the untrusted internet, and they're extending their voice over IP or telephony solution to their regional branch offices and remote offices over the untrusted internet. That brings in a whole slew of security vulnerabilities. As a matter of fact, I'm doing this right now in the end of 2008, and we've already isolated over 175 unique vulnerabilities from over 50 different types of groups of vulnerabilities and attacks on voice over IP, and it doesn't matter who the vendor is, whether it's Avaya or Cisco or Nortel, the attacks are there. And the hackers are using a wide variety of attack methods that are attacking voice over IP all the way up and down the TCP/IP stack, at the application layer, at the transport layer, at the internet layer, all the way down to the physical layer as well. So telephony is wonderful. It's saving companies hundreds of thousands of dollars, but like any new technology, it's just a breeding ground for new hackers and malicious users to exploit and get access to sensitive and confidential data. Alright, in this nugget on network design elements and components of the Security Plus exam from CompTIA, we looked at 5 key knowledge areas. We looked at demilitarized zones or security zones, talked about VLANs, network address translation, network admission control, and Microsoft's NAP goes along with that, and then finally, telephony. I hope this CBT nugget's been informative for you. I want to thank you for viewing. We'll see you in the next nugget. Take care now.